Hello everyone, this is lecture 5 from the chapter Light, Reflection and Refraction. In this lecture, we are basically going to discuss about the laws of refraction and we are also going to talk about the refractive index. So let us first have a look at the laws of refraction. The first law says that the incident ray, the refracted ray and the normal to the interface of two media at the point of incidence all lie in the same plane. So what does this mean? That if this is the incident ray coming in and there's a change in the medium, so the refracted ray also will pass in the same plane. That means it's a two-dimensional process, and you can well imagine something that is two-dimensional always stays in a plane. So this is somewhat similar to the first law of reflection. The second law, which is the most important one, also known as the Snell's law, says that the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. So sine I upon sine R is constant. This is the mathematical formulation of Snell's law, but we can understand it in a better way by with the help of this ray diagram. The incident ray forms an angle I with the normal, which is the angle of incidence, and the refracted ray forms an angle R with the normal, that is the angle of refraction. So according to Snell's law, sine of angle I divided by the sine of angle R is a constant for a given pair of media, and we consider this constant to be n, where n is also said to be the refractive index of the medium. That means whenever you will calculate the ratio of sine I upon sine R, let us say between air and glass, you will always get the same value. The value will not change, and that value will give you the refractive index for the ratio between these two media. So this is what is Snell's law, a very, very important topic for your exams, very frequently asked in the exam. Now let us understand what is refractive index. So when I say refractive index, it is the measure of the light bending ability of a medium. That means how much light a medium can bend. That is what is meant by refractive index. And the material which has the highest refractive index in the universe is diamond, which has a refractive index of 2.42. So this is the value of refractive index of diamond. And please remember that refractive index does not have any units. Then there's another term that you need to know, absolute refractive index. So what is absolute refractive index? It is the refractive index of a medium with respect to vacuum. So absolute refractive index is the ratio of speed of light in air divided by the speed of light in the given medium. So speed of light in air is always fixed. The answer is, or the value is 3 times 10 to the power 8 meters per second. And the speed of light in medium can vary depending upon what the medium is. So generally you get questions based on this, where either the refractive index is given and you have to find out the speed of light in the medium, or the other way around, that the speed of light in medium is given and you have to find the refractive index. So speed of light in air or vacuum, this is constant and you have to memorize this value. Let us now solve a numerical problem on this. So in the question, light enters from air into a glass plate having refractive index 1.50. What is the speed of light in glass? So as I said earlier, what is given to us in the question? We have been given that the refractive index, that is n, is 1.50, and we have to find out the speed of light in glass, and we know the speed of light in air or vacuum is 3 times 10 raised to the power 8 meters per second. Also, the formula for absolute refractive index is n is equal to c divided by v. So when we have to find out v, it's going to be c divided by n. So when we substitute the values, this becomes 3 times 10 to the power 8 divided by 1.50. That makes it 2 times 10 to the power 8 meters per second. So that is the answer to this question. So the speed of light in glass here is 2 into 10 to the power 8 meters per second. Now there are certain factors which affect the refractive index, and these factors are velocity of light in that particular medium. So depends on what the velocity of light is, So the refractive index may undergo a change according to that. It depends on the nature of the material of the medium. What material is actually used to make up that medium, and also it all depends on the wavelength of the light that is used. There's another way in which you may be asked a question based on the refractive index. So suppose out of the two media that are involved, we don't have air or vacuum. So it's medium 1 with respect to medium 2. So what to do in such a situation? So suppose we have to find out the refractive index of medium 2 with respect to medium 1. It can be calculated in two different ways depending upon what information is given to us. So one way is speed of light in medium 1 divided by speed of light in medium 2, or it could be the refractive index of medium 2 with respect to refractive index of medium 1. So it is very easy to remember this, like refractive index of medium 2 with respect to medium 1 is refractive index of medium 2 divided by the refractive index of medium 1. It is simple. So what comes before goes in the numerator, what comes after goes in the denominator. Remember, this is for refractive index. For velocity, it is going to be inverse. That means velocity of medium will go up in the numerator and velocity of medium 2 will go in the denominator. The reason is that refractive index is inversely proportional to the velocity of light. So when we have a look at the formula for refractive index, it says refractive index of a medium is equal to the speed of light in vacuum divided by the speed of light in medium. So n is inversely proportional to V. So if refractive index of medium 2 is in the numerator, refractive index of the velocity of light in medium 2 will go in the denominator. So that is why it becomes inverse. Another question, if the refractive index of water for light going from air to water is 1.33, what will be the refractive index of light going from water to air? So this type of questions are again very simple. So if you know the refractive index of medium 1 with respect to medium 2 is 1.33, and you have to find out the refractive index of medium 2 with respect to medium 1, you simply take the reciprocal. So the answer here would be 1 divided by 1.33. And that gives your answer as 0.75. Remember, refractive index does not have any units, so no units are to be used here. Another one, this is a very important question from your NCERT textbook. The refractive indices of kerosene, turpentine and water are given to you here. So for kerosene it is 1.44, for turpentine it is 1.47, and for water it is 1.33. You have to tell in which of these material does light travel the fastest. So as I said earlier, refractive index is inversely proportional to the speed of light in medium. That means if the refractive index is more, speed is less, and if the refractive index is less, speed is more. So we have to find out the fastest one, that is the one which has the maximum speed. So the maximum speed would be in that medium which has the lowest refractive index. So 1.33 is for water, and that is why water here is the medium in which light travels the fastest. If you get the question in a different way, like in which medium does the light travel the slowest, then it would be turpentine because it has the maximum value of refractive index. Another question, if the absolute refractive index of glass and water are 3/2 and 4/3 respectively, what is the refractive index of glass with respect to water? So this is just what we discussed a few moments ago. Refractive index of medium 1 with respect to medium 2 is equal to refractive index of medium 1 divided by refractive index of medium 2. So in this case, medium 1 is glass and medium 2 is water. So for glass it is 3/2 and for water it is 4/3. So what does it make? It becomes 3/2 times 3/4. That makes it 9/8. So option B will be the correct answer for this particular question. I hope you understood the concept really well, the refractive index concept we have discussed in this particular video. And I'll shortly be coming up with another video on lenses. That will be the next part of the series of videos from the chapter Light, Reflection and Refraction. Stay tuned.